In this video, we're going to talk about Lab 4 and some of the important things to remember and to know about this lab. So first of all, on Canvas, you can see there's quite a few things here that you can look at. There's the schematic of the H-bridge, the write-up of the lab itself, and there's a couple of zip folders with some files that you'll need to use. There's also a link to the Pololu motor, and then there's the template for the lab itself along with the Dropbox. Okay, so if I click on the link to the motor, this is a different motor than the motor that's in your the bookstore kit. Notice that it has 48 counts per revolution, and the ratio is actually 34.014 to 1. So in terms of figuring out that's in order to figure out the how to turn the output shaft 10 degrees, 45 degrees, 90 degrees, whatever, you have to make use of both the with the encoder, the counts per revolution of the motor, and the motor is connected to this gearhead, which has a 34 to 1 ratio. So you just have to be aware of that. That's different than the one that you have in the bookstore, that you got from the bookstore kit. So So anyways, in this lab, the first thing you'll do is actually build an H-bridge driver circuit. So, up for the most part, up until now, you've used, a servo object or something like that to drive a motor. So now you actually create your own driver, and then you'll do a simulation, and then finally you'll, using you'll write some PID code and use the driver to drive a motor and move an arm back and forth between two different positions, and then dial in the gains. So what you should do before the lab is to try and take a pass at writing some of the software. We did have from the lecture, we looked at this code right here and talked about how this works. And again, it's important in this one to make sure you have a consistent sample time, because you're taking discrete steps in time. So for instance, if you're trying to determine the integral term or the derivative term, then you have to think that those things would change, obviously, if you change the time. In class, we've talked about this H-bridge already, and we're going to use option 2, wire it according to option 2. So the 5 volt to drive the chip is coming in from the, you can use the Mega with a shield, and it's important to remember that with the Mega, with that shield on it, to get the right voltage on all the pins, you have to have the battery plugged in and turned on. And then for the power supply, we'll just use the 12 volt. We'll just supply 12 volts to pin 8 down here. Okay, and then while I have this open, I just want to mention too, the two input pins are 2 and 7, right? That's to turn on 3 and 6 to the motor. Those are the outputs. So we want to make sure that these pins 2 and 7 don't float high, because then that could possibly turn on the current at 6 and 3. So what we can do is maybe use a 10 kilo ohm pull down resistor, like in the input pins in the Arduino. We frequently use a pull up. You set the pin mode and do an input pull up, but we want to keep these pins low unless they're actually getting a signal from the Arduino board to turn them on. So we would use maybe like a 10 kilo ohm resistor and pull them to ground, both 2 and 7. Now you can, we've talked a little bit about this question here about magic smoke and the different options you have the two inputs, 1A and 2A. And then you'll hook up a function generator to run the motor to make sure that this H-bridge circuit's performing correctly. And you can try different frequencies for your function generator and try and figure out which frequency works the best. And I'm going to have to stop here and pick up from the next video.